Awesome. Thank you, Grant. This is Aaron. I'm going to just talk about a little bit about our approach for developing the tool, but mostly tell you what is the tool today, and then John's going to provide a demo. But to start with, sort of, we were really excited to have this opportunity to propose on the project with the county, and we were leveraging some work we'd done with Sitka in the Tahoe region, and saw this to be a great sort of synergy and a good jumping off point from that work into the needs the county had. And so we took a few kind of key approaches from the very beginning and have carried those through. One is that this is a web-based application. It's a framework that really supports this multi-jurisdictional collaboration. Not everybody's inside of the same Esri enterprise, and so this provides an ability to authenticate different people and different users into the system. It also supports both desktop and field workflows, tablets, etc. Open source was a key decision. It was prompted by the fact that Sitka does open source work, and they have in the Tahoe area. We saw a good jumping off point to be able to realize efficiency for the county of Orange, and also the ability for this to support customization, prioritize enhancements driven by the Orange County permittees, but also potentially the ability to expand this into a larger community of folks that are interested in, in developing tools to meet these needs. And lastly, in the software development world, they call it agile development. We phased rollout. It was a get something in people's hands early, get them using it, getting feedback often, and we were able to do that really quickly, building on the open source code, and we got people using it within a few months after we started the project, started to get feedback, and used that to prioritize features and where people wanted to go with this. And that's been, a really, I think, a successful approach. So what is the tools? What are they today, and what are they in the future? It is a common web application login. We have different roles defined, administrators, jurisdictional managers, and jurisdictional editors. So ranging from folks that are responsible for the inventory and to those that are maybe field crews that are entering data into the inventory. So the inventory module is the first place we started, and this is a way to track in a consistent framework structural BMPs as well as their attributes and the inspection and maintenance logs associated with those. The first case that we spun into more of a calculation engine was the trash module. So this is bringing together asset information with other GIS resources to start to provide real-time quantifications of how, where people are in terms of their progress. And in progress right now for us is a modeling module that goes beyond that initial trash, more simple trash calculation framework into more of a full-fledged water balance and pollutant load model that syncs up with the assets that are in the system. And supporting all this, as Grant mentioned, that one of the keys is you can't just drop a pin on a map and get the benefits. You need to know what drains to it, and you need to know some characteristics of the land that drains to a BMP in order to understand its benefits. So incorporating a delineation workflows into this was also key. And this is where we've collaborated extensively with OC Survey as the managers of some of the stormwater network data and geoprocessing services, and we've built on top of those instead of replacing those in this tool. So the inventory module is a way to track structural BMP assets, their attributes, observations, which are effectively inspection observations that change over time and are intended to characterize the condition, maintenance tracking attributes, quantities tracked by maintenance crews when they're in the field and maintaining these, as well as a place to store the design and O&M documents right alongside of this asset in a web-based platform. So this is, we've configured it for Orange County. We started with the BMP types that are in the Orange County technical guidance document for land development projects, and we've added other BMPs like trash BMPs and low flow BMPs that are more relevant for other aspects. But we've configured 24 types of BMPs and their associated observations in the tool. One of the key decisions we made from the beginning is for this to be configurable by county administrators, by users of the tool, so that if over time they want to add another BMP type or they want to change the observations, that's something that's in their hands to do. It doesn't require coming back to the software developer to support those changes. And so this also provides some extensibility to other user groups who might want to pick up this software, the ability to define the BMPs that are meaningful for your local jurisdiction or region. Field records are a key element that is designed to assess the more spatially temporal issues of, I'm going to go into the field, what am I going to do in the field? I'm going to potentially be improving my inventory, so able to collect more pictures, collect more attributes about a BMP that I didn't have in my existing records. But most importantly over time would be to record visual assessments, rapid visual assessments, and get a score about the BMP's condition and track maintenance. So this is a mobile optimized field workflow that lets somebody get out there on a tablet or a large phone and complete this. So assessments is a kind of a core function of this module. It's basically a rapid assessment methodology. It uses rapid visual observations and benchmarks and thresholds. So what are you seeing? What should the BMP be if it's an ideal condition? How far are we going to let it fall away from that ideal condition before it becomes penalized too much on a score? And then how do we weight these different observations? So this is a simple set of observations for a hydrodynamic separator, mostly focusing on pass-fail observations. Is it broken? Are there clogs? But then in terms of an analog observation, be the material accumulation in the system being an indicator that would drive the score. Other BMPs like bioretention, you might also be looking at vegetative cover, you might be looking at scour, you might be looking at a few other things to help define the condition of that BMP. Another key is the development site inventory. So everybody who has an MS4 permit anywhere in the country basically has been imposing requirements on on new development and significant redevelopment projects, and so these have accumulated since the 90s in people's planning records. So this is intended to provide a common place where the attributes and the locations of these projects can be inventoried, as well as uploading documents and associating structural BMPs with these plots of land effectively. And then finally, helping folks meet their annual or semi-annual or every 4-year type of O&M verification requirements for these land development projects by providing a form that can be completed in the field or at the desktop. So that's the inventory module in a real nutshell. It collects a bunch of information, but what are we going to do with it? I mean, one thing you can do with it is just simply look at it, filter the grids, view the dashboards to see which BMPs are in the most need of maintenance, et cetera. That's just a standalone inventory module function. But as we start to think about what do these assets mean relative to my progress towards requirements, the trash module is the first case where we've paired this BMP information up with spatial resources to estimate progress. So it gives a portal for folks focused on trash to get in there and manage their land use layers, their alternative and priority land use layers, add attributes to their BMPs to indicate what level of trash capture that BMP provides. On-land visual trash assessments are a key part of trash amendments compliance, and so the ability to perform those in the tool is important. And then based on the intersection of those three things to be able to provide a progress report. So in terms of the BMP side of things, setting the trash capture performance rating, uploading or delineating in the tool, the drainage areas to these BMPs, and then the trash amendments require regular inspections to document these are still working. So being able to attach those inspections to the BMP via the field visit workflow provides that record that I have a BMP out there, it's here, it treats this area, and it's being regularly inspected and maintained. OBTA is one where you're going to be out there doing some transects. Ideally, the person in the field is able to assign a certain drainage area or a certain influence area for that transect and say this transect and this score, which is associated with trash loading, corresponds to this area. And so we built a workflow that syncs up with the parcel data set for the county assessor's role that allows someone to walk a site or walk a transect and define and refine their study area for each transect, their assessment area, I should say, as they go, and then return to that assessment area over time and conduct repeat assessments, collect pictures, collect notes that support the score, the OBTA score that they provide. This then can get rolled into accounting methods for how much load is coming off of that site. And then the results maps. We look at the results in a few different ways. One is just simply area-based, and this most syncs up with the Track 1 compliance, but focused on how many priority land use areas are we treating with full trash capture or full trash capture equivalent. Also providing a view of load-based results. So even for jurisdictions that aren't in Track 2 now, giving them an assessment of where would you be sort of on load-based equivalency if you were to transition into Track 2. And then OBTA results, so being able to look at your jurisdiction on a map and see where different OBTA scores are more prevalent. So that's the inventory module and the trash module in a nutshell. And now I'm going to turn it over to John to give you a demo of how this kind of looks and feels in operation.